Hey everyone, let's dive into something we use every single second, but maybe don't think about too much: electricity. I mean, it's literally everywhere, right? It powers our phones, our lights, our entire world. But here's the crazy part. How does this one single force do so many different things? How can it create heat and also motion? Well, in this explainer, we're going to pull back the curtain and see how electricity is the ultimate energy shapeshifter. Okay, so think about this for a second. You've got an electric bulb, a heater, and an electric motor. One gives you light, one gives you warmth, and one, well, it spins things. They seem like totally different gadgets doing totally different jobs. But here's the thing. They all have one invisible, powerful force in common. Any guesses what that is?
You probably guessed it, right? It's electricity. And its most basic, most fundamental effect is something we've all felt: heat. Yeah, before electricity was running our computers and all that complex stuff, its very first trick was just getting things hot. Hot enough, in fact, to glow. So how does that even work? Well, imagine electricity flowing through a wire. It's kind of like a massive crowd of people trying to hustle down a really narrow hallway. The electrons, those are our people, are constantly bumping into the atoms of the wire. And all that bumping, all that microscopic friction, that's heat. Simple as that. There's a fancy name for it, Joule's law of heating, but it all boils down to that one powerful idea: when electricity meets resistance, things warm up. And you see this principle in action literally everywhere. That old-school incandescent light bulb, the little filament inside gets so ridiculously hot from all that electrical friction that it glows white-hot. That's your light. Your electric kettle, it's got a special coil designed to create a ton of resistance, dumping a massive amount of heat into your water and boiling it in just a couple of minutes. And a space heater, it's just a machine that's been perfected to do one thing really, really well: turn electricity into pure, cozy warmth.
But hang on a second. A force that can boil water in minutes? That's some serious power. And if you don't control it, that power can be pretty dangerous, right? So how do we make sure our gadgets are safe? How do we protect them from a sudden, destructive surge of all that energy? The answer is this little thing, the fuse. And honestly, it's a work of genius in its simplicity. Inside, there's a tiny wire with two very special properties. It heats up super easily, and it melts at a really low temperature. It's basically a little bodyguard for your appliance. If the current ever spikes to a dangerous level, poof, that little wire instantly melts, breaking the circuit. It sacrifices itself to save your expensive TV or computer. A tiny hero.
Okay, so we get that electricity makes heat, and we know how to keep it from going haywire with a fuse. But how do we actually, measure this invisible stuff? How do we put a number on its power? Well, we do that with a concept called electric power. Now, power isn't about the total amount of energy you use, it's about how fast you're using it. Think about it. That high-powered electric kettle we talked about, it absolutely gulps down energy super quickly to boil that water. But a tiny little LED light, it just sips energy really slowly. That's the difference in power. And it's all captured in a beautifully simple formula. Power, which we call P, is just the result of voltage. Think of that as the pressure in the system, multiplied by the current, which is the flow rate of the electricity. That little equation, P equals V times I, is the secret key engineers use to design literally every electrical thing you own. So, to get those numbers for voltage and current, we need a couple of special tools. First, you've got the ammeter. It measures the current, the actual flow. So you have to connect it in series. It's like you have to cut the water pipe and stick a flow meter right in the middle of it to see how much water is going through. Then you have the voltmeter. It measures voltage, which is the pressure difference. So you connect that one in parallel. You don't cut the pipe. You just put one gauge here and another one further down to measure the drop in pressure between those 2 points. Totally different jobs, totally different ways of connecting them. All right, but heat is just the tip of the iceberg. Electricity has this other, almost magical side to it, a deep, fundamental connection to a totally different force of nature. Here's where it gets really cool. Anytime an electric current is flowing, it creates an invisible magnetic field all around it. And this is no accident. Electricity and magnetism aren't separate things. They're two sides of the exact same coin, called electromagnetism. And figuring out how to use this connection, that's how we get electric motors to spin. It's the key to unlocking electricity's real power. And this is where everything we've talked about really comes together. See, the true power of electricity isn't just that it can make heat or that it's connected to magnetism. Its real genius is that it's the ultimate energy shapeshifter. just look at this. A dynamo takes mechanical motion, spinning something, and turns it into electricity. An electric motor does the complete opposite, turning electricity back into motion. A solar cell, it takes light from the sun and turns it into electricity. A battery turns chemical reactions into electricity. A microphone captures sound waves and converts them into an electrical signal. And what does a loudspeaker do? It takes that signal and turns it right back into sound. In every single one of these, electricity is the middleman, the universal translator between all these different kinds of energy.
So when you really think about it, electricity's true power isn't in what it is, but in what it can become. It's the ultimate converter. It's the bridge that connects the spinning of a turbine, the light of the sun, and the sound of your voice. And that just leaves us with one massive, fascinating question. As we build our future, what new, incredible transformations are we going to ask electricity to perform for us next? Thanks for tuning in.